Could you perhaps remind us what was your thinking? What was the initial inspiration, initial thoughts when you saw the works, and what it evoked in you?
Okay, thank you. Well, thoughts form and they also evaporate. So I don't know exactly what I had in mind, but I think I can reconstruct it, which was I was seeing the sculptures being placed, and it encouraged me to think about the role of the observer, the beholder, in art as compared to science. And I'm sure others are better qualified to talk about the role of the beholder in art. I can imagine that's very interesting, and that people who produce art think about the impact that will have on people, and that therefore influences what they produce. I can imagine that's especially the case in performance art, where sometimes the beholder is part of the artistic production. But in my mind, I was contrasting that with the role of the observer or the beholder in science. And up until about 1920, people thought that objects in the world, like a sculpture, were there, whether or not there was anybody there to see the sculpture or not. And objects in the world have properties, and these properties could be measured. Some properties might not have been measured, and then we're ignorant of them, but in principle, we can go and measure them, and they exist in that state before we measure them. And about the 1920s, it was realized that at the smallest scale in the world, that's no longer true. Quantum mechanics is an inherently probabilistic theory of matter, and it's a very, very strange theory. So it has an inherent randomness to it, and you can't really speak about something having properties before they're measured. The act of measurement produces the property, and that's an inherent part of quantum mechanics. Some of our audience may have encountered the Schrodinger's cat experiment, not a real experiment, I hasten to add, where you put a cat in a box and a quantum process, which is inherently random, can fire off some poison, which might or might not, which would kill the cat if it's fired off. But if it's not fired off, the cat will live. And so if you're outside the box and can't look in, you don't know whether the cat's alive or not. And the cat's literally in some quantum superposition of states. It's both alive and dead. And it's only when you open the box that the cat either is alive or it is dead. It's the act of observing that forces it into that state. And this was deeply troubling to people early on in quantum mechanics, in particular to Einstein, who famously questioned whether this could possibly be true. He had an intuition that objects did have an intrinsic reality, whether or not they're observed. And he famously asked, does the moon exist if no one's actually observed it to exist? And in quantum mechanics, the answer is no. But it's not our everyday experience. And so I was merely looking at the sculptures and thinking, there is a quantum view of this, which is it's either there or not there. And if I've not looked at before I've looked at it, I don't know whether it's there or not there. It's in a superposition of states.
I mean, that is quite interesting because also that sculpture is like very heavy. So it kind of feels like the tangibility of the sculpture mostly feels like it is there. Do you want to make a comment on it? Okay. So my follow-up question for you, Jon, is like, thanks for brilliant revisit of that crucial moment for me, at least. Could you perhaps expand on your reception of the title, Forming a Thought, and in the context of quantum chaos and random matrix theory, which is your specializations? And it would be really pleasurable to hear about your interest in number theory in this regard as well. I know I'm kind of like drawing a huge kind of like framework for you, but it would be really great to hear your response to today's main title.
Well, I wanted to give an even more general response than that, which is the response of a mathematician, if I may. How do mathematicians proceed from a thought to a form? And what is a form for us? Well, it can be many things. And I'll say a little more about this later, but it might be an equation. It might be a quantitative understanding of some process in nature. It might be a question. And so I wanted to say a little bit about what mathematicians do. and what they like to do and what they're aiming towards. So mathematicians do like to think. Thoughts are very important to us, as they are to everybody. Mathematicians are particularly wedded to thinking and can think about a given problem, a particular problem, for days, weeks, months, years, decades. There are some problems that I've thought about ever since I was a student, and I think about them most days, certainly most weeks, and I can think about them. I think about them for a few hours if I'm driving along. So thinking is an essential part of the mathematical process, and it's a very creative part because one's really trying to explore the possible in one's mind. We very much like to verbalize. Surprisingly, mathematicians are thought of as being introverts, but when we're with other mathematicians, we're not. And a key part of converting a thought to a form for us is talking about it. We're very talkative. We meet for coffee every day. We discuss. And that process of sharing is critical to developing the form that we produce. We also, and I think we'll get onto this a little later, we write, we sketch, and we doodle. It's very rare that you meet a mathematician who doesn't have a piece of paper and a pen. And that's how we communicate. We talk and we write at the same time. And that combination of words and writing is critical. And that writing might be on paper. It might be on, actually, these tables are designed so that you can write on them with felt pens. And that's what we do over coffee. We talk and we share ideas by writing. We visualize. We like to, we use our computers to draw pictures, sometimes models of images that we really can't even comprehend. So these might be shapes in a very high dimensional space, in 1,000 dimensions, 1,000,000 dimensions, an infinite number of dimensions. One can't really produce sculptures or models of that, but one can try to draw pictures that capture the essence of that. And that's very important to us. We polish obsessively, like I'm sure people do who produce visual art. When we develop a form, we don't just stop there. We can polish it for, again, days, weeks, months, or years before we're prepared to release it, because we want it to be perfect. We rework things. So once we've had an idea and developed a form, we're very comfortable thinking, I'd like to have another go at that now, do it slightly differently. We generalize. We work from special cases that we understand, and then we use that to form general theories that we hope are true and that we then try to explore. I'd say we collectivize in that we don't feel we have ownership of thoughts and forms. We share them with other people. And so we're very comfortable that we might have a thought and that somebody else may then come along and take that thought forward and produce a different form. We feel comfortable with that. We experiment and we challenge. We criticize each other. We criticize ourselves, and that's a key part of the process.
I mean, this is an amazing, clear outline.
And this is now what we're aiming for. So if I have a couple of minutes, what do? We formulate questions, which are very important to us. And a key element of research might be to simply ask a good question. We make guesses. We, of course, solve problems when we're able to. Key part is making connections, seeing connections between different areas of mathematics, seeing that they're related, and that's an unexpected connection is tremendously important to how we think. We form new perspectives. We aim to see things in different ways. We use a word. We're comfortable using a word which I think many people in the art world are not comfortable with. We try to produce things that are beautiful, and we're unself-conscious about using that term. So we try to produce beautiful proofs. We aim to understand. We aim to discover. We want to be increasingly precise. So mathematics we think of as being ultimately correct or not. And we want to get the most correct description of the world. And we're conscious that there would be something better, but we want to produce that. And I guess finally, we want to be right. And this is where there's maybe a difference between the art that Conrad and others produce and what we do, in that Conrad has the luxury that he can produce what's ever in his imagination. We're constrained by being right about something, and we can be wrong. We can produce something and someone finds a mistake in it or says that doesn't describe the world. If we use your equation, it's inaccurate. And so we have the work behind us, this constant fear or hope. The hope is that we will produce something that's correct, and the fear is that we won't. And I suppose I'll finish with two analogies that are commonly used. So doing mathematics has been likened to walking into a room that's completely pitch black and you don't know what's in the room or where anything is, and you're groping around and you don't know where to go, and there's nothing that leads you in any one direction, but slowly you form, by feeling around, a sense of what's in there, and then you find a light switch and you suddenly understand what's in that room, and then you move on to the next room. Or climbing a mountain for the first time when you don't know the right route, and you're constantly searching for the best route, the optimal route, the safest route, the route that gets you to the top, maybe the most beautiful, aesthetically pleasing route. And that's what we aim to do. Now, I think you want me to talk about this later, or I'll whisk through it now. This is an example that I wanted to give of a form. This picture, think of this as the form. This represents something that's very important in mathematics called the Riemann zeta function. I don't need to tell you what that is. Just look at that picture and you see the colors and think of those as contour lines. Think of this as a landscape with contour lines. And we're very interested in the points where all the colors meet. Those are tremendously important. They're called the zeros of the Riemann zeta function. And if you walk vertically up through that line of zeros, you see a picture like this, which you might imagine as walking on a landscape along a ridge of some hills. You go up and you go down, and we'd like to understand how high you go and how low you go. And this is a tremendously important problem. It's been a problem for 160 years in mathematics to understand the shape of this ridge of hills that I'm showing you there. And there's been tremendous progress in the last 10 years by taking a formula that we've known for 160 years and realizing that it has a structure that we never expected. And now when we see this formula, we can't look at it and see anything other than this structure. But before we understood this 10 years ago, we had no idea that that structure exists. And that structure is actually perfectly represented in one of Conrad's sculptures, which I'm going to show you later and explain later.
So perhaps can you talk us through your approach to producing a thought? This kind of like, again, that relationship between form and that process.
Yeah, thank you. Is this working?
Yeah.
In the presence of my illustrious co-panelists, I feel like the first thing I have to say is that this is all a huge mistake. I've really fell into the profession of being a publisher and an editor totally by mistake. And now 15 years later, I'm still the director of Urbanomic, struggling small publishing company. My background is in philosophy, but what I've tried to do with Urbanomic from the beginning is to publish work which is on the edges of philosophy and abuts or crosses over or communicates with other spheres. So philosophy and art, philosophy and science, philosophy and culture, music. And all this happened because in 2007, I decided to publish this journal, Collapse. One way of describing this, if I were to try to psychologize myself, would be to say, here is a person who found they were profoundly allergic to specialization and professionalization of knowledge. Something of a dilettante and a serial enthusiast with a personal dissatisfaction with the academic framework of philosophy. And after entering university multiple times, I finally decided to turn my dissatisfaction into a kind of personal project. So it was really accidental, but it was driven by two motives, one negative and one positive. The negative one is that I find that university philosophy, academic philosophy, was a very constrained discipline, which tended not to communicate very much with other practices and modes of thought. The positive motive is that I think everyone does philosophy. Everyone encounters philosophical problems, usually when the established conventions and regulations and rules of whatever your sphere is don't work anymore. So I think everybody eventually, now and again, encounters a philosophical problem. And I wanted to provide a place to do philosophy in the way that I understood it, as a kind of inventive conceptual thought that happens in all sorts of places when things break down. So I wanted to bring together people writing in different registers, authors from different worlds, different disciplines, and published writers, also philosophers who wouldn't necessarily find a voice in the academy as it was. So Collapse was kind of conceived as bringing the eclecticism of a magazine together with the serious intent of an academic journal. Could we go to the next slide? So usually I would think about a journal as being a space which has a clear demarcation, circumscription of the kind of content, the criteria for what could be included in it. And at a higher level, this communicates with the university model of knowledge as a whole. University obviously means you have this universal model of knowledge within which you have disciplines and then sub-disciplines, and there's a kind of structure of knowledge that's presupposed in that very idea and the way in which universities carry out their business. And of course, now we have a lot of interdisciplinary work, but what does interdisciplinarity mean? It's a very contested term. It often serves just to introduce an interface between one sub-discipline and another without really disrupting the circumscription of the disciplines themselves. So my idea for Collapse was to be undisciplined and transversal. So unlike in academic journals where all the contributions are circumscribed within a subject area, and that circle is then contained within these concentric circles, what I tried to do was to create a kind of montage with artists, scientists, theorists from different disciplines, people writing fiction, artists, with each contribution overlapping slightly with the next one. So you end up with this weird kind of connected chain where the two extremities of the chain, you might have two contributions that have absolutely nothing to do with each other, but they would be connected by these intermediate links. So that really became my editorial work in kind of forming, putting together other people's thoughts. So for instance, my favorite volume, I think, volume 7 on cookery, talks about materialism, cookery. It has theorists, philosophers, anthropologists. It has articles on the history of industrial agriculture, the use of chili as a weapon, the meaning of synthesis in mathematics, the artist Gordon Matta Clark's art cafe, anorexia, how the discovery of cooking food helped define the evolution of the human brain, predation and cannibalism, and the link between pigs and whey powder. So all this, I think, the way I try to think of it is as a different topology of the concept, and one that I think is more contemporary than a hierarchical delimitation of specialisms. And it allows us within one volume to trace out the multidimensional space of a concept, to take that concept through all these different worlds, and to produce, as I said, this kind of montage, a journey. Now, the second interesting thing about that is it also assembles a new audience, because people will often pick up one volume knowing one of the authors and they get introduced to all this other weird stuff. So it's actually produced an audience for our work that probably wouldn't have existed. So to come to the question of form, if what we're doing is trying to connect together all these things, why not just do it on the internet? Because you have hyperlinks, you can link everything together, you can create this kind of sprawling web of knowledge. A few reasons. One is my self-worth as an editor, because I need to think I'm doing something. And I think the editor is like a kind of lens, like a kind of concentrator. So I have my particular interests and my history and the people who I've encountered. And, you can go away and produce your own journal and yours will be different from mine. I think there's a kind of focusing function. The second one is sequencing. In a book, you have a linear sequence. And so you're kind of, as an editor, you're guiding people through this weird journey through different disciplines. And the most important one, I think, for me is commitment. It's that when you put something into a book form, you're making a statement. You're saying, I've put these things together. You can think I'm crazy or stupid or wrong, but I've done it. It's a commitment, and I'm going to publish it and put it out there. Now, things have moved very fast since 2007. So where are we with the book form today? When I printed Collapse 1, I think, as I remember it, I had to print 1,000 copies because that was the kind of viable number. Nowadays, of course, you can just put an ebook out. We're selling more and more ebooks. But also you can do print on demand. You can just print one copy of a book. So the progress of technology is actually changing the nature of this venerable book form and what it means to publish, to form thoughts into this format. So yeah, these older forms like books may retain qualities and advantages that newer forms don't have, but forms themselves don't remain stable. And lastly, when put into a form, thought is still not fixed. Appropriately for this occasion with Conrad, and I met Conrad through doing Collapse, and he's featured in several volumes. And we actually ended up doing a project with Conrad where I put him in a room with a mathematician for a week, and we talked about the zeta function, in fact. So appropriately, I think of all this as being really a sculptural thing. Like when I'm putting this together, I think that I feel like I'm kind of squeezing things together, finding how the shapes can possibly fit. And in the end, I want it to have its own integrity and I want to commit to it, but it shouldn't be self-contained. The shape that I like, the form that I like for editorial work is that it has an integrity, but it also has strange spiky bits pointing out in different directions. It's not smoothed out. It comes with all these bits from other worlds still attached to it. So that's kind of my inner vision, if you like, of the form that I'm trying to create as an editor.
That is very, very beautiful. Thank you so much, Maya. And it's also kind of, yeah, it is also about, like, for instance, we were talking on the way here actually with Conrad. It's also about this kind of like, you know, proliferating further thoughts through encounters, and those encounters also kind of like project onto new meanings because everybody comes from a different background, different kind of, let's say, a set of perspectives of seeing the world, engaging the world, relating to the world, but adding this kind of like unprecedentedness of introducing, let's say, unexpectedness into a contextual engagement is quite inspiring, you know, like as you said, it's also not only proliferates the profile of audiences, but also it kind of like creates that, I think, playfulness of, or the potential of like even coming up with something that you didn't think so you wouldn't come up with, you know, like it's almost like an unthought can be, you know, perhaps attended for a split second of time before it kind of like flies off.
And I loved your use of the lens as an editor. It was actually reminded me of Brian Catling's, one of his way he described his process of teaching. And Brian was a tutor of mine at the Ruskin, and he was very much part of the reason this whole show came about, was this idea of taking people outside their comfort zones, putting an artist in a room with a mathematician, which sounds like it's a wild dog, but it wasn't that bad. It was, but it's really about this kind of import and export, and taking artists into the Maths Institute and mathematicians into an art context, and sort of really taking outside one's comfort zones and seeing what happens when that happens. But Brian likened his role as a tutor as holding a distorted mirror up to his students. So it was, again, this lens idea, but not preaching or kind of being a kind of some kind of guru, but like allowing that person to see themselves through you. So it just reminded me of that. So I thought it was important to mention that.
Thank you, Conrad. And now, Emma, thank you so much for joining us today. And many congratulations on your new role as the director. And as I informed our audiences, we've been already in touch almost 2 years ago now, and you've been an avid supporter. And we were exploring ways of collaborating with you while you were at Modern Art Oxford, and we were very much inspired by the exhibition that you curated of works by Ruth Aceba, who is a kind of a deceased artist, but her work came to prominence over the last years. Can you perhaps like introduce us Ruth Aceba's body of work, but also your curatorial approach in shaping the exhibition? So perhaps my question is a bit more practical, a bit more tangible, now that we've kind of like come through the steps of, you know, like mathematical, editorial, philosophical thinking. Thank you.
Yeah, thank you. And thanks for the invitation to join you here. So the exhibition Ruth Aceba was titled Citizen of the Universe, which was a line I saw in a love letter she wrote in 1948, and I was exceedingly taken with it. And I co-curated the exhibition with Rebecca Selter of the Stavanger Art Museum. And her work and her life actually was really unusual. And one of the reasons you'll see when you see the work, you see a little bit of it there, that's the cover of the publication that we did. So Ruth Shaw was born in 1926 in California. Her parents were Japanese immigrants. Her mother actually never learnt to speak English. So she was brought up in a very interesting moment of history. She has this kind of joy that she comes to through largely the most extraordinary education institution that she went to, which was called Black Mountain College, and I wanted to talk a bit about that. So if we look at the next slide, this is just a single shot of installation of a number of her sculptural works, as they're called. So each one of these works, they are exquisite, I mean, really extraordinary works. In terms of my approach, in terms of curatorial, I trained as an artist. I kind of live in my body in lots of ways. So one of the things I love about exhibitions is that you move through space. You're choreographing your visitors in terms of how they're moving through the space. You're highlighting just a small number of concepts and texts such that people can take a hold of those and explore the space and the ideas on their own terms, really. And so I'm really fascinated with her work because it slightly made me gasp when I first saw some of it in Mama New York, because it looks like it's just born of nature. And then you start to realise it's handmade. And then the more you see, the more extraordinary it is, because they're made from single lines of wire. There's no welding, there's no fixings. They are looped into themselves. There's two techniques. One is looping wire and the other is tying wire. Each basically drawing inspiration from how nature repeats rules, the same rule again and again and again to generate and grow form. Some of them are huge. Some of these are over 3 meters. They are suspended by their own weight. They're the largest volume, some of the largest volumes you can manage on single lines of wire to those, with the material just holding its own form intact. So completely extraordinary. And she came to this very distinctive individual language of sculpture when she was at Black Mountain College. She was taught, Black Mountain College was a progressive college, exceedingly unusual. Joseph Albers and Annie Albers were invited over from the Bauhaus in order to lead the program. It was an interdisciplinary college, very much based on ideas of John Dewey, progressive educationalist who believed in whole person education and coming at education in an interdisciplinary way. What the Albers did was they put art education at the centre. So everybody had to do that as a core way of exploring, engaging with the world, particularly training with Joseph Albers. He was brilliant at training people how to see the world as an artist. And as you can see, quite unusually, here's some of his wire exercises he would get students at the Bauhaus to do, which had a huge influence on design. And again, it was about how do you make a volume of space. And what he was trying to teach was something we then still get taught in art school, which is how to perceive and make line, as in draw, around negative space. So how do you start to switch your visual perception so that you move into what some call a right-brained mode? It's exceedingly wordless. And it's such that you don't see a bottle there because that would be really hard to draw. But actually, you kind of get into a zone whereby what you're seeing is contrasts in negative and positive space. And by being in such a different headspace, you're able to create spatial and visual things such as drawings or sculptures. So next. Ruth Shaw was very influenced by Buckminster Fuller. She wasn't actually in his class. Buckminster Fuller, some of you will know, very experimental, super charismatic, super eccentric, interdisciplinary, wove together lots and lots of different ideas with great energy, very much coming out of, and it's this period kind of from the 20s on when there was far more influence of Eastern thinking for various reasons, but coming out of this move against ideas of static, certain knowledge, and much more influenced by ideas that the world is a continually changing and evolving set of living things, and that failure was a way in which you could try and find new form. The geodesic domes that we're all familiar with started as this failed experiment in a summer school at Black Mountain College. He bought Venetian blinds. The idea was to use the least amount of material to make the most voluminous space. So you can see where Ruth Sauer drew that idea from. And it completely failed. But they improved it the next year around. And his ideas, what you see here as well at the back there, I think it might be the next slide too. Some of the other teaching that was key in this extraordinary college, again, different way of making form. On the right, we see what became Ruth Sauer's kind of motif that then moves into her sculptural form. But at this point, she's expected to be a painter. The lovely photo montage on the right here by her friend is a picture of Ruth Sauer in Jon Cage and Merce Cunningham's dance class, which they were very fascinated by Buddhism. So ideas of dance and movement from Merce Cunningham, for example, that was not about synchronicity in space, as we might think conventionally if we were about to do a ballet together, but instead that how do you form your body such that it moves through time? And so these very different ideas were really opening up our understanding of what it is to be an individual in the world, in relation to others and in relation to something larger than yourself. And that's what drives my curating, what I'm fascinated in exploring. Different perspectives on that, different ways of understanding that through different individuals' subjective perception of the world and how we can learn from that and apply that to our own understandings. So the next slide. This is the best known image of Ruth Sauer. This is her, so the person she wrote the love letter to. They fall in love and they get married and they go on to have many children. And she continues to make her work all her life and also does community projects separate from her own individual works. But this ingenious way of creating works that means that she can work at home whilst also being a mother and being very community-minded is absolutely extraordinary. I included this because it showed that when she did do teaching, so her and an art historian friend and some neighbours set up in the elementary school arts education because they felt it was so poorly done. And one of the things that Ruth did was they brought in professional artists, professional musicians and others to teach. As you can see, some of the things that Ruth would teach is actually things she learned directly from Buckminster Fuller at Black Mountain. So the big circle is done with paper plates and hair clips, and it's a way of folding and piecing it together. But the story that goes along with it as it's being put together is from the story of philosophical idea around us being parts that complete a whole that is part of the big circle of life and being part of the universe. And there's this fascinating relationship in Ruth's understanding of mathematics about being something that's within the world to make sense of one's place in the world that I was very taken with. And then the last slide, I'm trying to gallop through this because it's meant to be 5 minutes. This I included because this is Ruth comes up with this way of using recycled milk cartons. They're actually really hard to get now. But in order to, it was a very children's rights and children's first moment in the 70s, and this is California. And so all the projects were very orientated around how do you encourage children to work together to create something larger than the whole, something they can work on collaboratively. And her and Bucky came up with these brilliant milk carton constructions, and her daughter worked with her and some others too. And I was really taken. I just want to end on this with this really beautiful. So Ruth, there's a few things that are really striking. The citizen of the universe concept that I was so taken with. I, of course, did that kind of rabbit warren thing you do when you're trying to make sense of where on earth did she get this idea from. And it wasn't super apparent where it comes from, but she probably learnt it from Bucky Fuller. And the place that's most striking to me that it probably comes from is Leibniz, actually, and, Mr. Monad's. And there's a really nice, there was at that time, Bertrand Russell had written a very popular book for students to understand philosophy. And there's a really lovely, slightly simplified articulation of Leibniz's idea, which I do wonder if she came across this, was introduced to it. Contemplation enlarges our actions and affections. It makes us citizens of the universe, not only one-walled city at war with the rest. In this citizenship of the universe, it consists of people's true freedom and their liberation from the thraldom of narrow hopes and fears. And she talks about her tutors, including Max Den, she name checks as well, as having taught her and profoundly influenced her outlook on the value of life and the true nature of freedom. So this idea of a citizen of the universe, giving you an identity beyond your immediate mother, daughter, immigrant, different roles and narratives that were happening there. In the introduction for teachers, this is a class that they then make into something that can be rolled out across schools. It's an incredibly successful workshop program they did. In the 1981 introductory pamphlet of how to teach this for maths or art in elementary school, I was so taken with this lovely, succinct articulation of forming a thought into form. It opens with this description for teachers. The usual approach for geometry in school is to start with plain geometry and then proceed to solid geometry. However, the three-dimensional world of solid objects is much closer to the student's experience. And bear in mind, John Dewey was all about learning from experience, and the experience is how we engage with the world. So, however, the three-dimensional world of solid objects is much closer to the student's experience, as the British mathematician Grace Young had already pointed out in the 19th century. So, of course, I looked into her because you can't help it. And she was writing brilliant books on how young people can understand the world if you make with them paper models of geometry and other things, and that they can really start to engage with abstract ideas, which resonates with their experience too. So to go back to Ruth, by dealing with the objects, the child can touch and move and even toss them around. More of the senses are involved, and learning can take place naturally and in the spirit of fun and exploration. This approach to learning has been discovered and rediscovered many times. People have worked with art and mathematics to mutual benefit in both fields. So I'll finish it there, but there's lots of interesting resonances between the multidisciplinary and the intergenerational learning and passing on that I know resonates with you, with Brian, Catelyn, and the rest of them.
No, that's fantastic. It reminds me also of another pioneer in her field of Maria Montessori, and her kind of coining of the phrase psychogeometries. Yeah. So that wonderful idea of how geometry has all this potential, and that was a thing she did in preschool, in nurseries, before there was language, to promote neural pathways and ways of thinking. She would put sequences of color, of geometry, of form, repetitions like this, and that arrival at complexity quickly through the repetition of something simple is, I think, at the core of a lot of what we're all talking about here, and within nature. But it's also then trying to extract those simple cores from the complexity we have around us, getting back to that kernel, that essence, that atom.
Yeah, thank you so much for all your eloquent presentations. I mean, as we have a method in, I think, both that crosses maths and arts and sciences and philosophy, is I want to kind of interject with a counter thinking and ask you about suspension and disbelief. So perhaps can you have your, perhaps talk about any experience where you had to go through the suspension of disbelief, and then in a way, kind of let's say, because for instance, John, when you were talking about the kind of steps of arriving at a form through a mathematical thought process, that you were also having the stage of challenge, and then when that challenge kind of collapses, what happens?
No, so I think actually this happens on a very regular basis, in that there's a psychological element to doing mathematical research, in that you want to solve a problem or get to a certain end point, and you go a certain distance and you reach a point where there seems to be an obstacle, and it seems to be insurmountable, and that can be very discouraging. But you then have to suspend your disbelief about that and sort of ask, well, what if I could get round it? What would the world look like on the other side? And you've got to force yourself to look at this obstacle from a different direction, and perhaps train yourself to think that it could be solved. And almost the act of doing that allows you to solve the problem. So it's almost like you've got to persuade yourself that disbelief can be suspended before you can then circumvent the problem or cement it in some way. So it's a key part of, in my view, doing research, is forcing yourself to constantly say, I think the world's this way, but I'm going to suspend that and persuade myself that it might be some other way that I don't understand, and then try to reconstruct from that point of view.
If we kind of used your climbing the mountain analogy, is it like building an additional bridge to take a leap to come back to where you were?
Yes, or it's if I'm not a mountaineer, but I've watched films about it. You get to a certain overhang and you think no one has managed to get over this before, and therefore I can't do it. But the people who do get around that overhang are the ones who persuade themselves that it is possible, that their disbelief is actually just psychological. And so I think a lot of the way that one trains one's students is when they come to this obstacle to just think, well, now enjoy things. Now just play with it. Try to find any way around it, but you can do it. And it happens. It happens occasionally. A lot of the times you fail, and a lot of mathematical research is constant failure. And the resilience that one needs to then pick oneself up is very important. But if you train yourself to be resilient, you find that some obstacles can be surmounted.
Thank you. And about you, Maya, because you kind of like, it was amazing. Thank you for giving the examples of like what could be in an edition or in a volume of a collapse. But I believe there is this kind of, let's say, invisible balance, like I think as an editor, you kind of like, even though those subjects feel so disparate and diverge, they actually kind of, let's say, kind of still balance of each other. And do you have any experiences where it falls off? It kind of, yeah.
Well,
or
yes,
collapse
of
is all
course,
about
and
idea of that never having that balance, or
no, it certainly is a balance. And when I talk about it as being, for me, a kind of a sculptural experience, that's very much what I mean. That I can, if I have any skill at all in being an editor, it's in stepping back, looking at how all these pieces fit together, and thinking, it needs something more here, or we need to change the order of these things, until you reach some kind of satisfactory state where you think this is a real thing, this gels together, and I can commit to it, and I can put it out there, and I'll be happy with it. But I was just thinking about suspending disbelief. I would say in philosophy, it's also the rule rather than the exception, because all of the great philosophers are total maniacs. I mean, to think that you can expound a system that's going to explain everything in the universe ever, you obviously have to be crazy. And obviously, if you start doing that, thinking that it's going to be the one true system, then you've really lost your mind. But equally, you've lost your mind if you think you're going to start reading philosophy and pick at it and tell the philosopher why they're wrong, because then you don't get anywhere. If you just kind of read page one and say, oh, I object to this, I object to this, what you have to do is enter into these grand, gargantuan fictions that philosophers create and see how the world looks. See what it does to the world, because every philosopher is really, more than anything, a style of seeing the world, a style of thinking, a style of experiencing. So it's always to do with suspending disbelief, and listening to this story, and every now and again being so captured by it that you take something of that style away with you and you live it every day.
That's very beautiful. Thank you. And Emma, for you, I mean, it could be you could answer it curatorially through making an exhibition, or maybe sometimes discovering an artist, perhaps in the beginning that you don't think their work is strong, but you have to kind of like dive deeper, or I don't know, like how would you like to take this question? It's very open for you.
Thanks. I suppose that to my mind, what's interesting about curating projects, and I was, when you're at school, you're making your decisions. I was hedging between philosophy and art. So I've continued reading philosophy as a hobby, but completely shamelessly amateurish, kind of just enjoy it and didn't dive into it because there's ways of understanding the world that I get a lot out of. And similarly with artists or working on projects, usually there's some resonance, there's something, it sounds an unusual thing to say, and it always startles students, especially at the Royal College, when they say, what's led your projects? Why are your projects? They're very zeitgeist and everything else. I say, oh, it's anger. I said I live in my body in that way. When something's really frustrating me in, say, a public discourse, or there's something not being said, or there's some frustrating rigidity about how things are being looked at. So when I've been in Oxford for not too long, by way of example, some of the conversations around race and gender seemed to me rather assumptive and somewhat frustrating. And so this was in 2015. And so I invited Labeina Hamid to have her first exhibition, her first institutional exhibition, as an artist who had done brilliant stuff since the 1980s, opening up questions and exploring questions on race and gender through a very subjective but a very generous open lens. And so for me, exhibitions are always, they start from a question or a point of frustration. I don't mean that in a negative way, but when you just see exhibitions are part of a public conversation. They're a chance to debate things and explore ideas in very diverse ways. And so as part of contributing to that public conversation, thinking about which artists would resonate or be able to say something in a stronger way and take you on the journey with them. I think you should be changed by what you're working on, and that be open to learning, such to the point that you come away somewhat different too. And so a number of the exhibitions pretty much all they take such commitment. Exhibitions are harder to do than you might imagine. The logistics are completely up against you all the time, and that's the bit no one's interested in. So you have to just suck it up and not even talk about those bits. And so it's a kind of optimism over reality to basically commission art or get exhibitions to happen anyway, I think is one thing that happens for sure. And so to my mind, to have that level of commitment and passion in there, the same with, choosing to lead the Foundling Museum, you have to be so in love with something or so see the potential or the beautiful DNA that's within it to make that commitment and to make that leap. You don't know what it is, but sometimes there's something intuitive or something that speaks to you about, there's a bit of kind of grit in your sense of the contemporary space at the moment and what you might, with others, put into that to nudge things along.
Amazing, thank you. What about you, Conrad?
Is this for the yeah, no, but does this broadcast when this one record, or is this? So yeah, so I've always used a sort of device of kind of hiding there's a sort of cloak of those sculptures, which is a sort of, I guess, a bit of a disingenuous device or tactic, because I remember one time I was installing something in a window and someone rushing past stopped and said, "What is it?" And I began to explain that it was an artwork, and before I could finish, he was like, "Oh," and then just walked off. But the minute I told him it was an artwork, he completely lost. He was really interested in it before he could, because he had to deduce the function from the form, and there was a sense that this thing had some kind of useful purpose or some kind of rational intent. But actually it was very useful, this reaction, because it made me realize how powerful it is to kind of give these things this cloak of the rational or of a scientific or a mathematical model. And so with all these works, and it's why it's so nice to see them in this building and in this context, because there is this energy here where they oscillate between are these successful models or something, and they create intrigue and questions, and then all these augmented minds within the institute are seeing something different within each one. But I think that I've often used the suspension of disbelief in that way, where I'm constantly I'm trying to give the pieces the authority of the rational. I don't want them to be whimsical or kind of Heath Robinson-like, and it's one of the reasons I moved away from wooden structures in my early machines, is I wanted them to have the authority of the real, the authority of the machine, to lead people down a kind of postprandial, I guess, is in archaeology you call it, that garden path where you assume this thing had a logical function, but actually, in fact, it's irrational and it's functionless. But by through those devices, it asks many more questions than it answers, and hopefully has poetry. So I think the breadth of a proof of a good artwork is that everyone has a different opinion about it, and that breadth of interpretation is where you can really sort of, if there's a consensus around the object, it's probably not a very good artwork. But when everyone sees something different within it, then you really sort of think you're getting somewhere, and it's and you lose control. It's no longer your possession in terms of the meaning, and that's when I get really excited if I lose control of that meaning.
Thank you. I mean, it's a brilliant segue to our kind of like last question before we open to the floor, is that we ask our speakers to pick a work from the exhibition outside that they kind of like, that resonates with them. So maybe we could start with you, Jon. Oh, sorry. Yeah.
Yes, so I chose this one, of which there are two versions by the back door of this building. So you'll see it perhaps as you leave. And I alluded to this earlier. So I mentioned that what I like about this is the fact that it's a tree-like structure, and that each branch breaks up into smaller branches. And so you can imagine this going on forever. It's an infinite structure in a finite volume. So it's almost a good example of Ruth's work that you were speaking about earlier. And it's, in my language, a fractal structure, in that you zoom into a tiny bit of this sculpture, and what you see is an almost perfect reconstruction of the whole thing. And that, for me, is tremendously important. But the thing I love about this is that I mentioned earlier this understanding that we have of the hills and valleys of the Riemann-Zeta function, and that we've only understood relatively recently, last 10 years. And that's because we've understood that the formula that generates those hills and valleys has exactly this structure, this tree-like structure. Mm-hmm. And so we never knew that before, up until about 10 years ago. And now we can't look at that formula and not see something like this. And so every time I walk past this, it reminds me, of the formula, but also I think it captures beautifully the sort of beauty of the formula on a daily basis. So.
That's amazing. Maybe Emma, because we've already seen a glimpse of the piece that you've selected. Sorry, the slides are slightly jumbled, but...
Yeah. So having seen for a very short moment the work of Ruth Sauer on a slide, maybe you can see that this, to my eye, has some connection with it. Why I'm particularly taken with this work is, to me, it always seems like it's slightly moving, and I know that it isn't. And it's that lovely dissonance that you have with the sense that something's growing and moving, but yet your rational brain knows that it is still and fixed. I mean, it's a really, and in terms of the relation to the body as well, it's kind of very person-sized, which I really like. There was Latzauer was a big influence on Joseph Albus, and when he was teaching the students about negative space and the importance of understanding that, I think, to my mind, one of the best kind of codes and ways to understand that, if you're looking at this and thinking about this, or thinking of Ruth Sauer's work and thinking about it, I'll read out this short code, which is to talk about the importance of the void. And in, as many of you will know, in Eastern philosophy, the void is the essence and the most important aspect of life and the energy of things. And so this is a beautiful articulation, I think. It's a very simple one by Latzau. 30 spokes meet at the hub, but the void within them creates the essence of the wheel. Clay forms the pot, but the void within creates the essence of the pot. So essentially, the material aspect creates the unity of the form, but it's the immaterial, the aspects that we can't see, that science has now revealed there's plenty there, but that we can't see and that seems immaterial, and that is the essence of life. In Eastern thought, that's very familiar. It's called Ma in Japan. It's a much more familiar concept, but I think it's one that I love in tandem, and it speaks to me in this work and the work of Ruth Assaw.
Beautiful. Right. Thank you. That was really beautiful. I thought maybe it would be a good moment to show the Yeats Memorial because it's linked to this piece, but it's but also it was also linked, I think, to these ideas of we are because we are perceived. So this is a piece that follows on from the piece that Emma kindly just talked about, and it's got the same geometry. It's a fracture, this series, and I was asked to make a memorial to the poet Yeats. And so it's got this sense of a widening Gaia. But this one, instead of it having these rusty leaves all over the surface, which are all unique, and they're sort of suspended like a light bulb, almost like a light bulb that's shattered before it all falls to the ground. There's this sort of ghost-like field. But it's this one, in terms of what you were talking about, Jon, about the idea of quantum mechanics is without being able to perceive inside the box, does it exist? And that idea of that kind of philosophical kind of question. And with this work, as you walk around it, or as the sun shifts, the piece it only exists because of the reflection in the surfaces. And so you see yourself fragmented within it. You see the sky, the seasons, the sunset, the sunrise. So it's constantly shifting, but it only kind of exists because it reflects things around it. So again, it's this sort of it owes its identity only because it's being perceived by light or being hit by light. Without that, it sort of disappears. So I thought it was a nice comment, but also with the Rooster Sour thing, it's got this, hopefully that really nice thing where you really want to walk around the thing and see between it the interference patterns of the back and front. Yeah.
That was very beautiful. Thank you, Conrad. And sorry for the jumbling of slides, but Maya, maybe we could come to you.
Yeah, so this piece, Paradigm, I think what intrigues me about it is this, the structure whereby it has a kind of it obviously is a sequence. It has a kind of upward aspirational elan. It's kind of there's some kind of developmental process seems to be going on. And I can tell there's something mathematical happening, but I can't make out the exact nature of the process, how each shape develops one from the other. It has a definite direction, but it's somewhat unpredictable. And in the title, Paradigm, I see a reference to Thomas Kuhn's famous theory of the scientific paradigm shifts, whereby science is ultimately kind of conservative. It wants to retain the conventions that it has, but every so often there's this kind of breaking point where it has to give way and a whole new kind of paradigm takes over. And this makes me then think about something that's often occurred to me when trying to bring together philosophy, art, and science, different disciplines, which doesn't always work. And that is that these practices have each a different relation to their own history. So if you take science, yes, there are indeed these paradigm shifts, but what doesn't happen, the way some people misunderstand this, is that science doesn't just throw away everything that went before and start again. What happens is that what was there before usually becomes integrated into a new model as a special case, as happened with Newtonian physics and relativistic physics. How about philosophy? Philosophy is a weird one. Philosophy, it takes you a long time to establish yourself in the history of philosophy. Probably, I would say, at least 10 years to really start feeling confident and at home. And during that period, what happens is all the deep thoughts that you thought you had, you find out that someone else has had them, and they all have names, and they're all very well established questions in philosophy. So there are established landmarks, discoveries, and even innovations in philosophy. But at the same time, it has a peculiar relation to its own history, which is that it continues to inhabit its entire history in a way that other disciplines don't. There's no invalidation. There's no real superseding of one philosophy by another. So you can always go back to Plato, and indeed we always do. And so there's a kind of circulation within the history of philosophy, which to an outsider makes it look like, frankly, it's a massive waste of time because you never get anywhere. But what's important in philosophy is that we continually return to the same problems and we refine them and restate them in new and different ways. In arts, similarly, if you take what's the paradigm of contemporary art? If anything, it means you can use any of the practices and materials that have been used in art throughout history. But there are still some established historical moments. Modern art as such is now over in a sense. And for some artists, the worst thing you can say is that it's been done before. So the art world sees itself as this kind of collective inquiry, in which certain historical moments are established and you can't go back. And by doing that, it kind of disconnects itself from a kind of art that would be just to do with the beautiful, just to do with personal development. All of that kind of goes into the bucket of art therapy. I'm not saying this is the paradigm I agree with, but I think this is the paradigm of contemporary art as a historical thing. But also remember that history is also being reinvented. So it was not until the 60s that Marcel Duchamp was rediscovered and kind of crowned as the great forerunner of everything that would come after. There's always this kind of delving back into history and reinvention. So mathematics, it seems to me, is a particularly interesting one. Is mathematics about discovering things, or is it about inventing things? You certainly don't get all of mathematics at once. It occurs within history, but it's supposedly a self-consistent structure of truths which are, in some sense, eternal or always true. So what exactly do mathematicians do? I think John's enlightened us a bit already, but it can't simply be a case of logically deducing one mathematical truth from another. Otherwise, you could do that very quickly. It would be easy. Why does it take so long, and what exactly are mathematicians doing? Now, usually in philosophy of mathematics, people don't talk about this. They talk about this boring question about what's called Platonism. What are mathematical entities? Do they really exist? Do they exist in some other realm? Why are they applicable to things in the world? I think what's really interesting about philosophy of mathematics is this question of its historicity. Not what its objects are, but how it happens, because ultimately it's the question of how something new is possible. And in the European tradition of philosophy, this has been, I think, far more prominent. So in the interest of brevity, I just wanted to introduce you to two very interesting French philosophers, both of whose lives were tragically cut short by the war. Jean Cavaillés, in fact, is a national hero in France. But both of them, in their own way, they were friends, but their positions were very different, tried to address this question of what happens within the practice of mathematics. How can it be at once contingent and necessary? How are new mathematical truth produced? And that's really what fascinates me. And I think Conrad's works, in the way they cross over art, science, and philosophy, really, have made me think about these kind of problems which don't belong to any one of these disciplines, but which in a sense they share.
That is very beautiful. Thank you so much, Maya. I think this is the moment for a magical turn. So if we could turn off the lights.
We've got a tradition. Just need to find the power. Okay. So we've had a kind of tradition here where we put I brought a sort of some kind of shadow maker or light maker. This is the kind of last in the series I've made recently of the Slow Arc series, which started off with a very simple mesh cage and have evolved into these double-layered, double lights and different experimentations. And each time I make one of these cages, it's about a simple premise of like moving a light from one corner of the cage in a sinusoidal speed profile to the other. This one has a single light and a double skin with a very particular mathematical pattern that repeats on both surfaces. So like with Usawa, the piece has a kind of interference pattern through the skin, and as you walk around it, you get the moire effect. But you also are getting a surprising effect as the piece moves. And are you able, one of the big questions with these works is, are you able to get back to the object from just seeing the shadows? The last one I showed in this room had a rhombic mesh, and there was a triple cage. So some of you may have seen that. You can see that on YouTube. This one and that one, the rhombic mesh has probably 80% of the material is removed through each layer. So you're getting more than 50% of the light penetrating through the layers of the sort of Russian doll of the cage. With this one, so the perception of that is you see the structural shadows on the wall, and they are perceived as shadows. What's interesting with this work is that the amount of light that is able to escape the cage, escape through the skin, is less than 50%, and suddenly the shadows are no longer there. All you see are these dots or these particles. And so it suddenly becomes more starry, more like sort of moving particles of light. And that's a perception thing. The critical point of moving past 50% means your cognitive way you perceive this thing shifts. But then what you see through this interference of these layers is that a particle appears and then drifts across the sky, if you like, and then disappears and then reappears. And you're getting these moments of kind of disappearance and reappearance and interference, and you're getting these perspectives. And I think, again, this is, for me, it's really sort of analogous, of course, to us observing the universe and trying to figure out. And as Jon mentioned, the being in the dark room is a perfect metaphor here, where we're trying to turn on the lights. We're all trying to see beyond our perception envelope. As artists, we're trying to see that through the repetition, endless repetition of an idea on canvas or in sculpture, of carving or adding. And with mathematicians, the endless experimentation, the refinement, that beautiful, all those descriptions that Jon made, and and Asawa's work, and philosophers, it's all about trying to see beyond, ingeniously see beyond our perception envelope, and to work out the truth of why we're here, of what we are in, and how we inhabit this strange and extraordinary sort of environments. This is the last of the series of cages, and I work as an artist in very much in the same way as maybe a mathematician and maybe a scientist, in that each time I make one of these cages, I just change one thing, and I don't know what the result will be, and sometimes they aren't that successful, and sometimes it's extraordinary. But it's often just the simple repetition of something simple leads to something really, really quite breathtakingly complex. And that's always why that eureka moment when is so exciting, when you turn the piece on for the first time and see the effect, which is very different from what you expected. Great.
Thank you so much, Conrad. And thank you so much for coming today. Thank you, Emma, Maya, and Jon, for your immaculate contributions. I'm afraid we ran out of time, so we won't be able to take questions here, but we can have questions outside. And thank you, Mathematical Institute and Dairo, for making this project happen. And really, this is the last time of our lecture series, so thanks for coming and taking part. And goodbye from us.
I just wanted to thank, because it's our last lecture, to thank Fatos Ustek and all of our panel, but Fatos has been extraordinary to work with on this wonderful thing. And of course, the Math Institute has been wonderful to host this. And I'm really excited the show's extended as well.
Yeah, thank you.